Hello and welcome to C Programming, Chapter 5 Array. So, the topics we are going to discuss in this chapter is the concept of array, one-dimensional array, and two-dimensional arrays. So, in this chapter, we will learn how arrays are defined, declared, initialized, accessed, and this chapter will also discuss the different operations that can be performed on arrays elements and different types of arrays such as one-dimensional and two-dimensionals. So imagine we are in a situation where we have 20 students in a class and we are asked to write a program that read and prints the marks of all of these 20 students. In this program, we will need 20 integer variables with different names as shown in figure 11.1. Now to read the values for these 20 different variables, we must have 20 read statements. Similarly, to print the value of these variables, we need 20 write statements. If it is just a matter of 20 variables, then it might be acceptable for the user. However, imagine it will be possible to follow this approach if you have to read and print marks of students in 100 students or 500 students or 1000 students. That is a lot of data that we need to key in one by one if we use the definition variables such as integer student 1, integer student 2. That is too much to write. Okay? So how do you use array to solve this problem? It is a collection of similar data elements, and these data elements have the same data types, such as integer, floating, or characters. The elements of the arrays are stored in consecutive memory locations and are referenced by an index over here. Alright, we'll see an example easier to see later down the road. Okay, some examples where the concept of an array can be used include the following: the list of temperatures recorded on every day of the month, or the list of employees in one company, the list of students in one class, list of products sold, or list of customer. This is one of the example that we can use, or how you would see the use case of array. Okay, why we need array in C programming? So imagine where you need to find out an average number of 100 integer numbers entered by user. So there are two different situations over here. Define all of those 100 variables ke semua 100 data tadi with integer data types, and then perform 100 scanf operations to store the entered values in the variables, and then at last calculate the average value of those 100 variables. Or have a single integer array to store all the values, loop the array to store all the entered values in array, and later calculate the average. So let us take a look at one-dimensional arrays. So in here there are a few key points that we need to know, which is data structure. So it is a format for organizing and storing data, and this is how it would look like, should look like in your diagrams. So to see it clearly, there are 5 different data here, and the data will always start at number 0 to it will always start at number 0. Even though it is number 4 over here, we have 5 datas. Array is a data structure which you can visualize like mentioned just now, and imagine an array as large chunk of memory divided into smaller blocks of memory, and each block is capable of storing data value of same type. Okay, these are two different arrays, and the first one consists of 10 data values, and the fifth one contains 5 data value. So if you set the array as 10, there are only 10 data value inside the array, while if you set it as 5, there is only 5 datas inside. Okay, so like I've mentioned just now, one array can only store one type of data. For example, number one, it only includes the data that can be recognized as integer, int. And the second one is recognized by character, A, B, C, all the letters. But the data type of any array cannot be mixed, such as the bottom. It cannot be mixed with integer value, cannot be mixed together with characters or floating value. Okay. So to declare a data type, an array must be declared before being used. Declaring an array means specifying three different things, which is the data type, name, and size. It is similar to how we use integer x equal to 4, for example, from our previous examples before. Though in array, there are three different things that you need to declare to get it working. So it starts with the data type, such as integer, and array name. Any name can be used as long as it follows the rules. It cannot be two different name over here. If it's two different name, it must be separated by the spacing. It cannot be too complex. Just give a simple name to the declaration of array. And then the array size. You can put 5 to 1 to 10 to declare the value of the size in the array. This is one of the example. Integer array 5 semicolon. So here it is an integer declaration, and then the name is ARR only, and then it sets the data size to 5, the array size to 5. So to access an array element, just write array name, the array name, for example, ARR, it is ARR, and index. So like I've mentioned just now, it starts with number 0 until the number you have set before. If you set it as 10, the last number should be 9, for example. So here it shows that it is an ARR with the size of 5. And if you want to get data from each of these column, you use this kind of call function call. For ARR bracket 0, you will get the data from the bracket 0 over here. While if you write ARR1, you will get the data from memory number 1, and so on. Same goes for the others. So in here, there are few key points. The things that you need to take notice is that array have 0 as the first index. Okay, like I've mentioned just now, the first data over here, it is a 0 index, not 1. And if the size array is n, to access the last element, you must minus by 1. Also, like I've mentioned just now, if you set the size as 10, the final index is number 9. Suppose the starting address of mark 0 is 2120D, then the next address will be 2124D, address of 2 will be 2128D, and so on. It is because the size of the float is 4 bytes. This is not really used that much, so do not take notice of this information. Okay. The length of an array is given by the number of elements stored in it. The general formula to calculate the length of array is length equal to upper bound minus lower bound plus 1. So if the upper bound is the index of the last element and the lower bound is the index of the first element. For example, if you put 9 minus 0 plus 1, The length is 10. See over here, there is the 4 and 0. So the memories represent of the array calculate in its length. Length equal to upper bound minus lower bound plus 1. The upper bound is 4 and the lower bound is 0. So 4 minus 0 plus 1 is equal to 5. So the size of the array or the length of the array is 5. Quite simple enough.